In this video, we will prove the chord segment product theorem. This theorem states that if two chords intersect within a circle, the product of the lengths of the segment of one chord is equal to the product of the lengths of the segment of the other chord. For instance, in the figure down there, we have the chords AP intersecting the chord CD at the point P. And we want to show that AP times PB is equal to CP times PD. Or equivalently, we should have AP over CP is equal to PD over PB. To prove this theorem, we will make use of similarity of triangles. Therefore, we're going to join the points AD to form another chord, as well as the points C and B. Now, by introducing these two chords, we will have two triangles, APD and CPB. And it's easy to see that those two triangles are similar to each other. Let's justify this claim. In fact, we observe that the angle DAP and the angle BCP are both inscribed angles of the circle intercepting the same arc. More precisely, we should have the measure of DAP equal 1/2 the measure of the arc. And we're going to pick a point here. Let's denote this point as Q. So the arc DQB is the arc intercepted by the inscribed angle DAB. Okay, and on the other hand, this same arc is intercepted by the angle BCD as well. So we end up with the equality between the measures of those two angles. And for a similar reason, the angle ADP and the angle CBP are intercepting the same arc, which is the arc ARC up there. So we conclude that the measure of ADP is equal to 1/2 the measure of the arc ARC, which in turn is equals to the measure of the angle PBC. And we could denote the congruence by putting some strokes down there. Furthermore, we also have these two angles, namely the angle APD and the angle CPB, to be congruent with each other because they are a pair of vertical angles. That is, the measure of APD equal the measure of CPB as vertical angles. Consequently, by the AAA, the angle condition, we conclude that the triangle APD is similar to the triangle CPB. Therefore, the corresponding side are going to be of the same proportion. Specifically, we should have AP over CP equal to PD over PB, which is exactly what we would love to prove for this theorem. So we're done.